Okay, so today we're going to review two things. First, how to calculate average rate of change. Second, how to use your graphing calculator to solve a system of equations. So what I'd like you to do is I want you to try number one as a do now. Remember, average rate of change is basically just slope. So I give you an interval for my x's. So the first x, I'm starting at -2 and I'm stopping at 4. We're going to calculate the slope given function f of x and function g of x. So pause the video and find the y values that go with each of these and calculate the slope between the points for f of x and then between the points that would go with g of x. Okay, at this point, you've calculated the slopes, and I'm going to review what your answer should have been. So for f of x, you just have to look it up on the table. So the y value that goes with f of x for -2 is 1.25. The y value that goes with f of x for 4, the output would be 80. So you're going to take the difference between the y's and the difference between the x's. When you take those differences, you get 13.125. For g of x, you actually have to calculate it. You could substitute it into your calculator in one shot. Make sure you're being picky with parentheses. So here the output is -49 when our input is -2. The output is 179 when the input is 4. Again, we're going to take the differences between our y's and the differences between our x's. And then we're going to calculate that that's 38. So if now I'm comparing the two rates of change, the interval that has the greater rate of change would be the interval going with function g of x, because 38 is greater than 13.25. Okay, the next type of problem that I want to review with you would be the same type of idea, but now I'm giving you a graph. So for number 2, we have a cardboard box that's being made by a manufacturing company. They graph it, and they want to know over which interval is the volume of the box changing the fastest on average. So what you want to think about here, if I'm saying the fastest on average, that's code for who has the greatest rate of change. So each one of these, they're giving us x's, and we need to look up the y's. So if I'm looking at choice 1, I would need to calculate if my input is 1, what's the output? If my input is 2, what's the output? So here this is going to be 0, and I'm just looking it up on the graph. And then when I sub in 2, I would say the output's probably close to 9. And I'm going to take the difference. Remember, it's change in y over change in x, so my change in y is 9, and my change in x is 1. So this is going to be 9 over 1, which is 9. And next we could look at the rate of change for number 2. So we would be going from 1 to 3.5. And we would look that up on our graph. So here, if I write my x and my y, I have my 1 and my 3.5. We already know the output for 1. That was 0. And then 3.5 would be between 3 and 4. So it looks like that's going to be like the maximum value that's right there. So I would estimate that to be about 17. So the difference here would be 17. And then my difference here is going to be 2.5. So 17 divided by 2.5 is definitely going to be something that is smaller than 9. So I'm going to get rid of this choice. And then I'm going to have you guys calculate the rate of change for 3 and 4. And then decide what your answer would be. So I'm going to have you pause it and calculate that. So after you guys have calculated your rate of change, you're going to end up going with choice 2. Okay. For the next one, we're using the same idea, but you're just using a table, and we want to know which one has the average rate of change that's the greatest. So I want you to circle this one. You're going to save this one to go back to. And then number 3, I also want you to save this one to go back. Number 4, I also want you to save this one to go back to for more practice. Okay, the only difference here is that we gave you a graph instead. So the second half to this lesson is solving equations graphically. So whenever you have a question where things are multiple choice, they say to the nearest tenth, and they want to know which one is not a solution, that means that we're going to be going to our graphing calculator to help us solve this. So they're saying for when these two things are equal to each other. So what that means is technically we're figuring out when this function is equal to this function. Well, things are equal to each other when they intersect. So basically, earlier in the year we solved systems of equations algebraically, and now we're going to solve them graphically, but we're going to use our graphing calculator to help us. So you're going to put this as your y1 in your graphing calculator, this whole equation here, and then you're going to put this as your y2 in your graphing calculator. Now I'm just going to flip to this. So here, my graphing calculator that I like to use for my recordings is not working very well, so I'm just going to show you guys a screenshot. If I graph, here I have this in blue is the p of x function, and in red I have my q of x function. So you see this line is crossing through my polynomial in 3 spots. So we need to look, and they're asking us which value is not a solution. So negative 3.9 ends up being a solution. And remember, if you want to be able to have your calculator, rather than estimating, to go to your graphing calculator and actually get the points of intersection, once you have things graphed, you're going to click second, trace, and then you go to intersect. When you click that, that brings that blinking spider. Remember, you have to bring the spider so you use the arrow keys to make it land right on top of an intersection point, and you press enter, 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 and the calculator gives you an estimate of where they intersect. So if you did that on your calculator, these 3 points are going to be places of intersection. 4.7 is not. Other things that are important for your calculator, if you cannot see the entire image of the graph, you're going to need to change the zoom. So I'm going to run through just a few more of these to point some things out to you. For this question, when they're asking for an approximate solution, you want to remember you're not looking for the coordinates of where they intersect. The solution is the x value that makes these two things equal. So automatically, you could get rid of these choices, and you're going to want to look at the graph. You're going to use your graphing calculator. You are not doing these by hand. And I want to remind you that if you need to get to absolute value, you're going to click the math button, number, and absolute value is written as like abs in the calculator. Okay, you're going to graph both of these on your graphing calculator, and you're going to look for where they intersect. If you cannot see their intersection point, you're going to need to change your zoom. For this last one, same idea. Now, technically, because they have this like this and they have the choices, you could try substituting these values in to see which one makes the choices, like which choice makes this closest to being equal. You could also, again, use your graphing calculator to see where they intersect, and you're just looking for the x value. Okay, so what I'd like you to do for the remainder of class time is I want you to complete the remaining questions. When you've completed them, you can show the sub and they will give you the rest of your, they'll give you your homework for tonight. Okay, I look forward to seeing you guys on Friday.